In this lesson, we're going to learn how to simplify radicals. This is a process done in math to maintain the exact value of our radical, as often many times the square root will come out to be a decimal, but it also creates the smallest number possible inside of our square root sign, our radical symbol. Let's get started. The first step in any of these is to find the factors of 75. So values like 1 and 75, or a factor pair of 3 and 25, or finally a factor pair of 5 and 15. The next step is to identify if any of those factors are in fact perfect squares. That list of perfect squares is in your notes as well as right here in our chart. And what you'll notice is 25 is in fact one of those perfect squares. So we are going to select this factor set right here to then perform our product rule with square roots. And that is best done by listing the perfect square first as square root of 25 and the times the square root of 3. Since the square root of 25 can be taken as a perfect square, we will do that. As 5, the square root of 3 is not a perfect square, so we will simply just leave that as the square root of 3. And there is your final answer. 5 times the square root of 3. Number 2. Our factors of 48 are 1 and 48, 2 and 24, 3 and 16, 4 and 12, finally 6 and 8. In this case, we have two values in different factor pairs that are perfect squares. My advice to you is to pick the factor pair that has the largest perfect square in it. So that will be 3 and 16. And now we do our product rule. The square root of 16 will go first. Square root of 3 will follow. Square root of 16 is 4. The square root of 3 is not a perfect square, so we will leave that as the square root of 3. And there you have it. Number 3. Now you may look at number 3 and realize that this is already a perfect square on its own and that our answer is 8. But I want to show you something in the process just in case we get to larger values that you don't recognize as perfect squares. Watch what happens. If I do my process, 1 and 64, I've got 2 and 32, I've got 4 and 16, I've got 8 and 8. You'll see right here, both of these in the same factor set are both perfect squares. That's your first indicator that you already have a perfect square by itself. But if we continue our product rule, I'll put the biggest one out front like I always do. So the square root of 16 times the square root of 4. The square root of 16 is a perfect square, that's 4. The square root of 4 is also a perfect square, that's 2. They still need to be multiplied, and 4 times 2 is the 8. So again, that's how you'll identify if you have a perfect square to begin with, and that you'll find a factor pair that both factors are perfect squares. Let them work out and they'll come out to an exact answer. Number 4. We have the square root of 70. So the factors are 1 and 70, 2 and 35, and 7 and 10. I also have 5 and 14 in there. Looking at that complete list, none of those are perfect squares, factors. So what that tells us, believe it or not, is that that square root is already reduced. So we're just going to leave it as the square root of 70. There's no simplification possible. Number 5. Again, our factors here are 1 and 120, 2 and 60, 3 and 40, 4 and 30, 5 and 24, 6 and 20, Got a long list here. 8 and 15, 10 and 12. Out of all of those numbers, there's only one of them that is a perfect square, and it happens to be that 4 there. So doing as we always do, we'll put our perfect square first, and its partner second. The square root of 4 is a perfect square as 2. The square root of 30 is not a perfect square, so we're going to leave it as that big square root of 30. And that, again, believe it or not, is a simplified radical. Pause the video here, complete problems 6 through 9, and then come back and double check your answers. So I have my factor list here for 16. The only perfect square factor we have is that 4 there again. So we have square root of 4 times the square root of 15. Square root of 4 is a perfect square as 2. Square root of 15 is not a perfect square, so it stays as 2 square root of 15. So here are all our factors of 200. We actually have several of those factors as perfect squares. But again, the advice is pick the set that has the largest perfect square in it. It requires the least simplification at the end. So we have the square root of 100 times the square root of 2. Square root of 100 is our perfect square, that's 10. The square root of 2 is not a perfect square, so it must be left alone, and there you have it as 10 square root of 2. Here again, a lot of our factors are perfect squares, with the largest set being here, 2 and 36. So we'll go to square root of 36 first, square root of 2 second. That leaves us with 6 square root of 2. For this, the list is much larger, but because I've already found a nice perfect square that's in the larger side of the list, I'm going to use that group. So square root of 64 times the square root of 5. Square root of 64 is a perfect square of 8. Square root of 5 is not a perfect square, so we leave it inside the square root symbol. And there you have it, 8 square root of 5.